How big is the number 5? Well, on a number line, the number 5 lives there, and we could say that, actually, I don't put it there, I'm going to put it underneath. There's the number 5, and we could say that how big is the number 5? We'd probably say it is 5 big, and we can think of that as meaning that this distance from the origin to the number 5 is a distance of 5. It doesn't really make sense. It's not 5 centimetres or 5 anything's really, it's just 5. But that's one way of thinking about the number 5. And in a way, the number minus 10 is sort of bigger than the number 5. It sort of makes sense that minus 10 is bigger, even though it's not bigger as in a sort of number comparison way. Minus 10 isn't bigger than 5, no, but minus 10 is sort of bigger than 5. Okay, I'm bluffing slightly, it's not really, but it sort of is. And it is in the sense that the distance from the number 10 to the origin is a distance of 10, whereas the distance from the origin to the number 5 is a distance of 5. So the modulus function identifies that size, it identifies how big a number is. If a number is positive, the modulus is just the same as the number, because that's how we measure numbers, and if the number is negative, then it's the same as the number, but you ignore the minus sign. So in the examples that I did, the modulus of 5, which is written like this, modulus of 5, that's just 5, because that's how far away 5 is on a number line from the origin, and the modulus of minus 10 is 10, because the distance of the number minus 10 on a number line from the origin is 10. It's a distance of 10. So what would the graph of mod x looks like? Y equals mod x. Now, basically there isn't a graph of mod x. Well, there is, but it's two graphs, because if I think of all the x's that are positive, like this, then y equals mod x, well, all of them are positive, so the modulus of x is just x, because it's the distance from the origin. So if x is positive, then the modulus of x is just x. So the graph of y equals mod x is just the same as the graph of y equals x. That's it. But if I've got negative x's, then the graph of y equals mod x, all of those negative x's are going to be changed to positive, because they're always saying is with the modulus is how far is it from the origin. So if this is my minus 10 there, the distance to the origin is 10, so I'm plotting it at a height of 10 up here. So this is 1 away from the origin, so I'd plot it at 1. Basically all of these numbers are negative, and the modulus of a negative number is the same number but positive, which I could write as minus x. There's that positive there. So when I take the negative side of the graph, the modulus of x is the same size as x, but instead of being negative, it's positive. So overall, the graph looks like this. But really, it's two graphs. The red bit is the graph of y equals x, and the blue bit is the graph of y equals minus x. And together, those two make the graph of y equals mod x. How would I draw this graph? Y equals mod x plus 3 plus 1. Well, how would I draw this graph? Y equals x plus 3 squared plus 1. I would say to myself, okay, I'm going to start with an x squared graph. That looks like that. Then I'm going to go inside the function f of x equals x squared, and I'm going to add 3, f of x plus 3, to get x plus 3 squared. So that's an inside transformation. That moves the graph left and right, and it does the opposite of what you'd think, so it makes it go left 3. So that's going to move it left 3, that's that bit dealt with. The general shape is the squared, and then the plus 1, well, if I now add 1 on to f of x plus 1 like that, that's going to move it up 1. So I'm going to go left 3, up 1, and then the graph of x plus 3 all squared plus 1 will look like this. You know this from C1. And you can identify the turning point as minus 3, 1. Well, we can do exactly the same thing with our modulus graph, It's just that the original shape isn't a quadratic, the original shape is a modulus. So here's the graph of mod x, y equals mod x. This part of the graph on the right is just the normal y equals x graph. This part of the graph on the left is the y equals minus x bit of the graph. And we are going inside that function. So f of x is mod x. We're going f of x plus 3, which is mod x plus 3. That's a left and right's going to move the graph left 3. And then we're going to plus 1 on the end, plus 1, and that's going to move the graph up 1 in the same way. So this bit's up 1, and this bit's left 3 from the original shape. So overall we end up with a graph which is the original graph, but left 3 up 1. Dunk, dunk, like that. And that's your minus 3 there. And that's your 1 there. If we wanted to know what the y-intercept was, we do exactly the same as we do in C1. The y-intercept is when x is 0. F of 0 is 0 plus 3, modulus plus 1. Modulus of 3 is 3, because it's a positive number, so it doesn't change. 3 plus 1, 4. So the y-intercept is 4. As well as sketching translations and transformations of mod x, you also need to be able to sketch mod f of x and f of mod x for a general graph, just like in transformations in C1. So let's look at the first one. What happens if f of x is positive? So all the way down here, f of x is positive, and this bit f of x is positive. Well, if f of x is bigger than 0, then that modulus sign doesn't do anything. Modulus of f of x is just the same as the modulus as f of x, so nothing happens. But when f of x goes negative, down here, f of x is less than 0, then the modulus of f of x changes that sign to positive. So the modulus of f of x is minus f of x, the f of x being negative, so overall this is positive. So what it does is it bounces it up like this. So this is the same as transformations in C1. This is outside of the f of x. Everything outside affects the graph up and down. What it does in the modulus case is it bounces stuff up that's negative. So anything below the x-axis gets bounced up onto the top, and then overall we get this graph here. So anything below goes up and becomes positive. Right, the second one. This is now inside. So we are inside the f, inside the brackets, which, as you know, affects it left and right. Now, usually we think of this as doing the opposite of what you'd think. And in this case, it really is the opposite of what you'd think, because you would never think it does this. Okay, let's think about x bigger than 0. If x is bigger than 0, then mod x equals x. So f of mod x equals f of x. There's no change. So there's the graph. Okay, what about if x is negative? If x is negative, so all this stuff, if x is negative, then f of mod x is f of minus x, where that bit's negative, so overall it's positive. So I'm doing the function f, even though I'm over here, I'm going to do the function f, but here it is, function f. I'm not doing it to x, my x. I'm not doing f to that. I don't care about this information here. I don't care that the function f takes this blue dot and does this to it, because before I do f, I'm going to change x to be positive. So I'm going to go ping over here. Then I get my positive x, I change it to positive, then I see what the graph does. Oh, it does that. That's brilliant. And that's the information that I bring back over here. So all of this information is lost forever. It's gone. Because we never ever do f of a negative number. So even though it's got this beautiful curve, that's going to go. So this is what happens. Gone. Totally irrelevant. Totally ignore it. So you cross out, well, you don't cross out, you never draw, left-hand side of the graph. So the left-hand side of the graph, I told you it doesn't do what you'd expect it to do. It does the opposite of what you'd think, in the sense that it does the opposite of what you'd ever even think for a second it would do. So all that gets scribbled out, no. And instead, everything that happens on the right-hand side also happens on the left-hand side, because all our negative x's get made positive before we do x. So that happens, the left-hand side gets crossed out, and the right-hand side multiplies over on the left-hand side. I will do another example of this, so you get the idea of the two different ways of doing it. Right, let's start with the mod f of x. This is outside, which makes us think up and down, and in this case all the down gets bounced up. Anything in here that's negative gets bounced up to become positive, and the graph of mod f of x would look like this blue line here. Okay, next one. This is inside. That makes us think left and right, and it makes us think that it's going to do the opposite of what we think. Now, I don't know what we think, but it definitely does the opposite. So anything on the left-hand side of the graph is going to get completely rubbed out, totally ignored, completely ignore it. And then anything on the right-hand side of the graph is going to get copied over, like that. So overall, in blue, this is the graph of f of mod x.